Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a very interesting question, which is left view of a binary tree. So you will be given a binary tree and we have to print the left view of it. So let us discuss the question first. So suppose we are given a binary tree, and what we have to do for now, just assume there is a person standing over here, okay, and this person is keeping an eye on this binary tree, okay. So when the person will try to see the left view of binary tree, then which nodes he can see like this. See, 3 is hiding behind 12. Person can, starting from the root, the person can see 7, the person can see 3, but he can't see 12 because 12 is hiding behind 3. Okay, the person can see, if the person turn his eyes to the down, then he can see 1. Yes, he can't see 6, 9 and 13 because these all are hiding behind the 1. Okay, so the person can see 4. Yes, he can see 4. Now assume if there are some nodes like this, there is 14, then 19. So just think of whether the person will be able to see the 19. Yes, the person can see 19, but person can't see 14 because in this level the 14 is hiding behind the 4. So now let us discuss some other points, how we will figure out this problem. See, the person can see 7, 3, 1 and 4. If we'll divide this tree in levels, then this will be level 0, this will be level 1, this will be level 2 and this will be level 3. If you'll notice a thing, that if we have to traverse level order wise, means like this is level 0, then this is level 1. If we'll traverse in this binary tree level order wise, then what will be the answer? We will travel at 0th level first, then at 1th level, which will be 3 and 12, then at 2th level, which will be 1, 6, 9 and 13, and to the last level 4. So we'll take help from this level order wise traversal. Means we are doing level wise processing. First 0th level is processed, then first 1th level is processed, then 2th level is processed, then 3rd level is processed. So here we are using level wise BFS. So see, when we are processing 0th level, then we need to first store this 7, and then we will call the children of 7, that will be 3, 12, and then what we'll call children of 3, and then we'll call children of 12, and then we'll call children of 1, which are nothing, then we'll call children of 6, that is 4 only, then we'll call children of 9, which is nothing, then we'll call children of 13, which is nothing. So this is how we'll implement to see the left view of a binary tree. So here what we'll be doing, we'll be using queue. Actually we'll be making queue using linked list. Okay, we'll be making queue out of it. Okay, how we will implement this thing? See, we'll basically use two functions of queue, which is add last and remove first. See, if we'll recall the question, which is level order wise traversal, then what we have learned over there, there is a separate question in the level 1, which is of level order wise traversal in binary tree. If you haven't watched that video, then first go through that video, then you will understand this thing very well, that what basically we used to do in level order wise traversal, okay, in a binary tree. So what we used to do there, firstly we will add 7 to the queue. Then what we'll do, we will see after in 0th level there is only one element, that is 7. So we will add all the elements of 0th level. So that is only 7. Now what we'll do, we'll add its children. We'll add its children and we will remove this 7. So basically we are adding from last and we are removing from first. Okay. So we are adding at last and we are removing from first. Okay. So after inserting the childrens of 7, we have removed the 7, and then what we'll do, this here level 0 is completed. So now we will make a call to children of 3. So children of 3 are 1 and 6. So children are added. Now what we'll do, we'll remove 3. And now next what we'll do, we will make a call to children of 12, which are 9 and 13. Okay. And then we will remove 12. Now what? Now we will call children of 1. But there is no children of 1. So we will add nothing and we will remove first. So what we are basically doing, we are adding, we are removing the nodes after adding its children. So first add the children, then remove the node. Okay, this is what we are doing. So we have added, we have removed 1. Now we will check for children of 6. Children of 6 is 4. We'll add it and we'll remove 6. Children of 9 is nothing, so we'll add nothing and we'll remove 9. So we'll check for children of 13. Children of 13 is nothing, so we'll remove 13 and we will add, so we'll remove 13. Okay, because it has no children. Now what is left? 4. Children of 4 is nothing, so we will remove 4. So if you will notice a thing, that whenever we are going into another level, see, whenever we are going into another level, the very first element of each level is the element belonging to left view of our binary tree. So what will be our left view of binary tree will contain in this particular tree? 7, 3, 1 and 4. So every element coming first at each level will belong to our left view. So 7 is the only element. 7 is the very first element in 0th level. 3 is the very first element in 1th level. And 1 is the very first element in 2th level. 4 is the very first element in 3th level. Okay. So this is how we will implement our logic. So let us move to our code section. Then we'll code for whatever we have done over here. So we are given a root in the function left view. We'll use this root. See, the very first condition is if root equals to null, then return null. And then what we'll do, we'll implement q. Linked list of tree node. So what next we'll do? See, now we will add, firstly we will add the root. Our very first work to do is we will add this root to our queue, which we have created just now, right now. So we will insert this root value into our queue. So queue dot add last, what this root value. Now what we'll do, see, when we have inserted the very first node, that is root, then initially when our size of queue was 0, so we will implement one more thing, that is size. We will make use of it. When we were inserting the very first element, which was root value, then our size was 1. Our size was 1. So what we were basically doing, we were adding the children of 7. We were adding the children of 7. So our size is 1 and we are adding the children of 7. And after adding the children of 7, we will remove this node. And when we'll remove this node, then we will also decrease the size of this queue. So this will become 0. As soon as it becomes 0, what will happen? Then again we will insert the children of next node. Okay, so our next node is 3. So we will first insert the children of 3, and then here our size will be 2, and we have inserted the children of 3. Okay, so after inserting the children of 3, our size will remove 3 and our size will be decremented by 1. Okay, and when the size is 1, again there is some element in the queue, so we will firstly add the children of 12 and then we will remove the 12, and when we'll remove the 12, the size will become 0. Again the size of queue is 4. Okay, so size is 4, and now we will insert the children of 1. So children of 1 is nothing, 0. Now we will decrement the size. Now we will remove 1. We will check for children of 6. We will add children of 6, that is 4. And after adding children, we will remove 6 and we will decrement the size. And then what we will do? We will add children of 9, which is nothing. So we will remove 9 and we will decrement the size. Now what we will do? We will add children of 13, which is nothing. So we will remove 13 and decrement the size. So this will become 0. Now what is the size? Size is 1. So we will add the children of 4, which is nothing. So size 4 will be removed and size will become 0. Okay. And when the size becomes 0, what we will basically do? After this, when size is 0, we'll check whether the size is great. We were doing all these things till the size was greater than 0. As soon as the size becomes 0, we'll come out of it. Okay, so till here the size is 0, so it will come out of our loop. So we will implement a loop for size of queue. Okay, while queue dot size is greater than 0. Okay, Then what we were doing? We were first, actually we were first adding the element. See, we are supposed to print the first first value, first node of each level. So as soon as we'll enter the inside the while loop, we will print our value, print our this value which is in the queue. So we will print value from queue. Okay, and see, we have to return array list over here. So we will create an array list of integer. We are supposed to store the integer values. Name will be answer. So what we'll do add this value into answer. Get first, then value. Okay, so this will be storing our first value of q, which is 7 3 1 4. Okay, how? So we will again create a variable of size. We'll store size of q, and we'll create another loop and we'll decrement this size. See, if you are not getting the things which I am doing right now, then no need to worry. We'll do the dry run of it. What we'll do, we'll remove one by one, we'll remove the nodes from the queue and we'll add its children. We'll be removing from the first. So if removed value of left not equals to null, then we'll add its children. Okay, and same thing we'll check for the right child also. So this is our code, and at last we'll return our stored answer. So for once, let us dry run this thing. I hope now it is visible to you. So So look at this. What we are doing over here, we have passed the root. Let me move this thing over here. So root was passed as 7. Root was not equals to null. This is first condition. This is second. This is third. Okay. So firstly the condition was checked. Then what we have to do? We have to create a queue. So let's create the queue. And then the size of queue is 1. How? Because we have added the root value in queue. So we have added the root value in queue. Now the size is 1. Okay. Now we will also maintain an answer. So this is answer. So we'll add this value in our answer. Q dot get first dot value. We'll add this in our answer. Now the size is 1. Size minus minus means 1 is greater than 0. Yes, for the next time it will become 0. But for now it is 1. So we will remove this 7 and we'll store in rem variable, and we'll check if rem dot left not equals to null. Yes, it is true. So we will add this rem dot left in our queue, and if its right is also not equals to null, then we will add this rem dot right in our queue, and we are adding at last. See, we are adding at last. Now for the next time size will become 0. So while size was 1, while size 0 greater than 0, condition is false, we'll come out of this while loop and we'll go up. So now q dot size is 2. For now q dot size is 2. Now we will add first value out of it. So we will add 3 in our answer, and now the size equals to q dot size, which is 2. Initially it was 1, then it became 2, then now size is 2. 2 minus minus greater than 0. Yes. Remove 3. 3 is removed. 3 dot left not equals to null. Yes, not equals to null. Then add 1. 3 dot right not equals to null. Not equals to null. So add 6. Now what? Now decrement the value of rem, which will be 1. Okay. Now we will remove this node and we'll check if rem dot left not equals to null. So this will add 9. Then we'll check for right. This will add 13. Then again it will become 0. So this condition will become false, and we'll come out of this while loop and we'll go up, and now the q dot size will become 4. Okay. Now again we'll add this answer dot add q dot get first value. We'll add this first value in our answer, and then we'll check for its children one by one. Size will become 3, 2, 1, 0. 1 is having no children, 6 is having 4 children, then 9 will be cancelled, 13 will be cancelled. Then at last size is 1. So when size is 1, when we'll come out of this while loop, we'll come up and q dot size is greater than 0. We'll add this into our answer, and we'll check for removed rem dot left, which is equals to null. So we'll simply remove this, and our answer will contain 7314. So let us submit our first run our code. So there's some compilation issue. Q dot rem first. Okay. Q dot remove first. So accepted, submitted. Okay. So it is taking time. Okay. So all the test cases are passed. So I hope you have understood this problem. So we'll be meeting in another video with another question. So thank you for watching.